Okay, so we need to take x squared plus 4x plus 4, and we need to factor, and that's going to factor as x plus 2 times x plus 2, which is the same thing as x plus 2 squared. Okay, so now let's do our restrictions. Of course, in both cases, the only thing that you have here is x plus 2. So you only have just the one restriction here, that x cannot be negative 2. Now when you pick your common denominator this time, I've got x plus 2 squared, and I've got x plus 2 that's to the first power. So I've got exactly the same factor, but this one's squared, this one's to the first. Remember, when you got the same thing, you go with a larger power. So that means we're going to go with it to the second power. So your first fraction, that is what you already have as your denominator, so this numerator doesn't change. Now on this one, this means you only have one of these. You have one x plus 2, and you need two x plus 2's. So that means you're missing one of them. So that means that I have to multiply the top times the x plus 2, like the one that's missing. Okay, so that's going to give me 2x plus 4. You can go ahead and distribute that as you bring it down. Now when I go to add, I've got some like terms, because I can combine 1x plus 2x, which is 3x, and 2 plus 4 is 6. Now let's look to see if we can do some simplifying. The simplifying that I can do here is I can take a 3 out. I've got a GCF. Okay, now there is some canceling. Of course, I've got an x plus 2 here, and I've got two of them here. So this one will cancel only one of those out, but that means you would still have one of them left on the bottom. So you've got 3 in the numerator, and now you just have an x plus 2 that's just to the first power. So you wouldn't have to put it in parentheses to the first power. Okay, next one. Okay, again, we need to start off by doing whatever factoring it is that we can do. And I can factor here, this is the difference of squares. So x plus 5 times x minus 5. And this would be x plus 5 times x plus 1. Okay, so when I'm picking my common denominator, I have to include, of course, I've got the x plus 5, but they're both just to the first power. But I also have to include the x minus 5, and I have to include the x plus 1. Okay, so comparing what we have here, here's what I've got, here's what I need. So I've got the x plus 5, I've got the x minus 5, I'm missing the x plus 1, so that's what I've got to multiply by on the top. Okay, here I've got the x plus 5, and I've got the x plus 1, I'm missing the x minus 5, so that's what I've got to multiply the top by. So let's go ahead and we can distribute the 4 and distribute the 6. So combining like terms, I can combine 4x plus 6x, which will give me a 10x. And then I have 4 plus negative 30, which is a negative 26. Now the only factoring that I can do here with my numerator will be to take out a 2. But even after I take out the common factor of 2, I still don't have any like factors that I can cancel out. So you actually could write your answer either way. even though I've already written this down, nothing cancels, you know, this would be a correct answer, but because nothing cancels, this would also be a correct answer because it actually ended up not simplifying. Simplifying means that you can cancel out some of your factors, and we can't do that here, okay? Just remember, if you notice, like I don't bother multiplying my denominators back out, because you want those to be in factored form, because when you get ready on this last step to start reducing, that's the way you need it. So don't ever bother multiplying your denominators back out. That's the only type of thing that you need to do on the top, okay? Like combine like terms, multiply things out, you know, and then do the factoring there.